Hey everybody, it's Tutor Pat, ready to put the fun back into functions with a discussion of everyone's favorite mathematical relationship. So what the F is a function? Well, hold tight because I'm about to tell you. So at its most basic, a function is a mathematical relationship where for every input, we get exactly one and only one output. Now we can imagine this as a factory. Not a terrifically efficient factory, but a factory nonetheless, where I can put in 1x. Something happens to it. The Oompa Loompas do something inside there. They could be adding, dividing, subtracting, multiplying, square rooting. That action is called the definition. And once it's done, so to speak, it comes out as a perfectly formed y. So for every 1x goes through, something happens to it, that we call the definition, and it comes out a y. That is the most basic understanding of what a function is. 1x to 1y. Now all my x's collectively, those are called my domain. And all my y's, all my outputs collectively, those are called my range. Now because every domain point, every x, is paired with exactly one y, we can portray or understand functions in a few different ways. To illustrate this, being an example, I've drawn these adorable pictures of eggs. Now you know you can portray or cook eggs different ways. I could hard-boil them, I could fry them, or my favorite, I could scramble them. But a scrambled egg is still an egg. It's no more or less an egg than a fried egg or a hard-boiled egg. It's just a different way to present the egg. That serves as a useful analogy for the different ways that we can portray functions. So functions, like eggs, can be prepared in multiple ways. The first way would be an equation. The second way would be a graph. And the third way would be a table. Now it's really important to remember that just like a scrambled egg isn't more or less of an egg as a hard-boiled one, a function written as an equation gives us just as much information as a function portrayed as a graph, which also gives us just as much information as a function organized into a table. Now, I say it's important to remember this because our teachers in school, they have a bias towards equations. When you're doing homework, you're most likely solving, simplifying, factoring equations. Occasionally, you are drawing graphs, right? But very rarely are you organizing things into tables. But the SAT and ACT give equal weight to each of these portrayals of a function. And in fact, they expect you to be able to switch between them. That switching is called functional fluency. Like linguistic fluency, where I can move from English into, say, Portuguese without any loss of meaning, the SAT and ACT expect me to move from an equation to a graph, or if they give me a graph, they expect me to take that graph and be able to generate a table, or to figure out the equation. That's functional fluency. Taking any one of those three forms and being able to move backwards and forwards to understand it as an equation, as a table, or as a graph. Now, just as school tends to weight heavily towards equations in terms of understanding functions, I've noticed that the SAT and ACT, especially the SAT, loves a table. And often the first step to solving a really tricky functional equation or word problem is to think about the equation in terms of, or the function in terms of a table. Click the next quick hit about the different function families to learn more about this pivotal mathematical relationship.